Hello. Hi guys. Srinu, Samatha.
Yes, I can hear you.
Uh, Right. So myself is Srinivas. I'm having 16 plus years experience. I started my career as Unix administrator. I worked on SCO Unix, Sun Solaris, HP Unix, IBM AX, Linux. I was into storage technologies, Veritas Volume Manager, Veritas Cluster, Net Backup, storages like SAN, storage area network, network attached storage. Now I'm into the cloud, Azure, AWS Cloud, and DevOps. In our environment, we have both AWS and Azure. So basically, I'm a DevOps engineer. We have a infrastructure, physical, and cloud, both. So what I'm going to take here, the cloud, AWS, Amazon Web Services. So today the agenda is, before we go for cloud, as a cloud admin, need to have knowledge on what are the servers, what is the meaning of infrastructure, to deploy your application, what infrastructure you require, and what are the application. As a cloud admin, we are going to work on some applications. We are going to deploy some application. So what kind of applications we have, and what is the physical data center, difference between physical data center and cloud data center. What are the problems, disadvantages in physical data center? Why we should go for a cloud? And who are the cloud service provider? Cloud service providers, and the difference between physical environment and virtual environment. All this stuff we discuss today. So AWS cloud, or not only AWS, any cloud, Azure or AWS, we need to have strong knowledge on operating system, either Windows or Linux. Especially for especially for AWS, we need to have knowledge on Linux. If you have Linux administration background, it's well and good. Even if you don't have Linux administration background, at least you need to have knowledge on Linux fundamentals, Linux basics, which you are going to which I'm going to take free of cost. Before we start AWS Cloud, 1 week we'll have one fundamentals, Linux basics. After completion of basics, we'll start the DevOps. Sorry, we'll start the AWS. I'll provide training on AWS, training on Azure, and DevOps. DevOps is the buzzword nowadays. So DevOps has a lot of demand. So we can learn AWS DevOps, or you can learn Azure DevOps, or you can learn only AWS. That is cloud infrastructure. In AWS, we are going to cover certifications, Amazon, solution architect, solution architect, and professional both. So nearly we are going to cover 40 services in AWS. Once you complete this AWS 40 services, you are eligible to apply 0 to 4 years experience. So I'll provide the training and support as well. Job support on AWS or Azure or DevOps. Right. So to deploy any kind of application, we need an infrastructure. What kind of infrastructure you require? You can't deploy application directly. We need an operating system. For operating system, we need a server. Without a server, we can't install the operating system. So infrastructure like servers, laptop, desktops, all these are workstation. It is not a server. Server means what? Having 32 GB RAM, 64 CPUs, 128 CPUs, all these are higher-end servers. So these servers we can take from the AWS cloud or Azure cloud. What kind of hardware capacity you require? Or we call it as a compute capacity. What is compute capacity? We'll see later. And storages. Why do you need a storage? The real time, if you purchase the server with 10 lakhs, 20 lakhs, they'll give the hard disk, internal hard disk only 500 GB. The 500 GB is not at all sufficient to store the data. It required more than terabytes of storage. So we need a storage. This storage we are going to attach to the servers. There are two types of storages, internal storage, external storages. We have a separate topic on this in AWS. What are the types of storage devices? What is SAN? What is NAS? What is internal, external storages? All this stuff we'll discuss later. And also we require switches and routers. If there are 5,000 servers network or more than 5,000 servers in the organization, don't think that all the 5,000 servers will have internet connection. Most of the servers will have most of the servers are in private network, not in the public network. In order to communicate the servers in a private network, we need a switch. Any server, if I connected to the switch, the server can't able to access internet. You want to add any server to the internet, we need to add the server to the router. We call it as a Wi-Fi router. So without router, we can't able to connect to the internet. So in the organization, we have both switches and routers. Switches for private network and routers for public network. A database server, production server, most of the servers are in a private network. Only few servers like mail service, web service, these servers are application servers. These servers are with public network, remaining all private network. So we cannot find an environment without switches, without routers, and many more. This comes under infrastructure. So we need this kind of infrastructure to deploy your application. So what exactly application? You heard about Flipkart, Amazon, Facebook, gmail.com, yahoo.com, all these comes under applications. All the net banking application like SBI, ICICI Bank, all this comes under application. So what are the types of applications we have? Applications are classified as three types: standalone application, web application, and mobile application. What is standalone? Whenever we install any operating system, some applications are by default installed, like camera, calendar, calculator. All these applications are by default installed in your laptop in Windows operating system. So calculator, camera, calendar, all this comes under standalone. The meaning of standalone, these applications you cannot access from remote system. My laptop applications you cannot access. Your laptop applications I cannot access. only from local system, not from remote system. That is called standalone. So these applications we install at the client operating system or end user operating system. Coming to the web application, these are classified as two types, static and dynamic. Web applications are hosted on remote system. Assume that this is my remote system on internet. I hosted Flipkart, Amazon, Facebook applications where these are hosted on remote. In order to access this application, what I require, I need internet connection. All these applications are hosted on internet. To access this application, you don't need to install any software in your local system. You just need a browser. With that browser, you are able to access these applications, which are called web applications. You might be having laptop or a tab or a mobile. If at all you want to access this application from your laptop, you don't require anything, any software. You just need a browser. Our tab also we need a browser. If it is mobile, we need to install mobile application. Flipkart, you can download this Flipkart application from Play Store or Amazon application, Facebook application. Download it in your mobile, you can access it. But require what? Internet connection. So these are the applications hosted somewhere on internet. We don't require the physical location of this application where these are hosted. So this web application again classified as two types, static and dynamic. Static and dynamic. In static web application, there is no human interaction between the user and that application. What I mean to say, we don't require any credentials, login name and password. We don't require any credentials to login name and password. Example for static is any e-papers like Deccan Chronicle, Enadu, any e-papers or comes under static. When you're trying to access this application, is it asking for credentials, login name and password? No, right? So Wikipedia, e-papers, all this comes under static. So in a static web application, we are going to deploy some data, static data. The meaning of static data, we can't able to modify that. We can't able to delete the content, modify the content. Only view the content. That is called as a presentation layer. There are three types of layers. Going forward, we'll discuss in detail. Presentation layer, application layer, and data link layer. Presentation layer only for graphical user interface, GUI mode, only to view the content. What are the programming languages which we are going to use to develop this static web application? HTML, CSS, JavaScript, jQuery, React.js, AngularJS, all this comes under programming languages. These guys develop this static web application which works on presentation layer. So once I develop this static web application, if I'm a developer, I develop this static web application with that application by default in my laptop. I want to host this application. I need a server. So you cannot host this application in your laptop. Why? Because a laptop is a single user. What's the meaning of single user? Only one user can log in at a time. Windows 7, Windows 8, Windows 10, all these are single user. To deploy this application, I need a server operating system. Server is a multi-user. Like in Microsoft, we have Windows 2012, Windows 2016, Windows 2019. Those comes under server operating system. Most of the people they knows only client OS, Windows 7, 8, and 10. Very few people know that server operating system. So as a Windows administrator, we used to work on server operating system. Even Linux also server operating system. So to deploy the static web pages, we need a server and server operating system. So once we take the one physical server having higher amount of memory, higher end server, we are going to configure the server as a web server. To deploy the static application, we need a web service. What are the web servers we have? Apache and Unix and HA proxy. All these are web services. With the help of these web services, we can deploy a static web application. And these web services available only on Linux or Unix. For Windows, we have a service called IIS, Internet Information Service. You want to deploy an application on Windows, we have to set up, you have to configure IIS. You want to deploy your application on Linux, you have to set up Apache, Nginx, or HA proxy. So going forward, we'll see how to set up your Apache web server on Linux. So we'll take the server from AWS Cloud, higher-end server, we'll install Apache software, we'll configure that, then we'll see how to deploy it. Coming to the dynamic web application. It works on application layer. So along with presentation layer, it need a application layer. Here, the presentation layer will communicate with application layer. Example for dynamic. Any net banking applications. These are comes under dynamic. Why? Because this dynamic web application required credentials, login name and password. When I click on continue to login, it asks for the credentials, right? Username and password. This is called as a dynamic. When you log in as an ATM user with ATM card, it asks for the PIN number because that is dynamic. Gmail.com, Yahoo.com required credentials, that is called dynamic. Facebook, Flipkart, all this comes under dynamic web application because we need a credentials. Even Google Pay, Phone Pay also comes under dynamic. So on which layer this application works? It works on application layer. So this dynamic web application, it works on three-tier architecture. This application works on three-tier architecture. Means what? We have one presentation layer, which is called graphical user interface. When you type flipkart.com, we'll see one interface, which is called graphical. That interface is called presentation layer. Application layer, it asks for the credentials, username and password. That is called application layer. After that, data link layer. Whatever information we are able to, whatever the data we are storing, where this data being stored in the database. The data being stored in the database. When you log into the Amazon, we can see the pictures. We can see the pictures. Where the pictures are stored in the database. That means what? That is called data link layer. This is called three-tier architecture. We need one presentation layer, application layer, data link layer. So what is three-tier? One front end. Front end. In front end, we are going to configure HTML, JavaScript, Angular, JS, all this comes under front end. Front end is nothing but a graphical mode, GUI mode. And this front end will communicate with middleware. This is called application layer. This is called application server. What are those? Tomcat, JBoss, WebLogic, WebSphere, all these are application server. As a DevOps engineer, we need to have strong knowledge on what is this application layer, how to set up this, how to configure this. And then we need a backend. The backend is what? Database. 10-15 years back, a lot of demand for Oracle database. But now, in place of Oracle, we are using MySQL, MS SQL, MongoDB. All these are comes under database. When you log in as an ATM user with ATM card, you're able to see how much amount you have, where the data is in the backend, in the database. How you're going to access this data with the help of this middleware. When you provide the credentials, where the credentials will be stored in the database. So the process will, whatever credentials we are providing here, with the help of this application, it will send that information to the database server. Get the credentials from here. So this is called presentation layer, application layer, data link layer. So to develop this presentation layer, we need a developers. We need a developers. Those developers we call UI developers. UI stands user interface. They're going to develop this front end application. So this presentation layer will communicate with application layer. The application layer will communicate with data link layer. So the moment you get the credentials details in bank, in the backend, it will call it as a API. API stands application program interface. That API send that information to the application layer, from application layer to data link layer. That is called database. So this presentation layer communicates with the application layer, that we call it as a API. API stands application program interface. So who is going to write this API? There are separate developers. We call it as a API developers. API developers will write this API, application program interface. What programming language they are going to use? They are going to use Java, Node.js, Python, .NET, Ruby. All these are programming languages. With these programming languages, they are going to write APIs. So the application layer retrieves the data, where the data is storing in the database server. The application layer retrieves the data from the database server. So this is called as a three-tier architecture. So as a cloud admin, you need to have knowledge on what is front end, what is middleware, what is back end, where the data being stored, what are the types of layers we have, what is the use of a presentation layer, application layer, data link layer. All this stuff is required as a cloud admin. In fact, cloud admin required OS knowledge, networking knowledge, what is IP addressing, what is subnetting, what is switch, what is router. Cloud admin required storage knowledge, database knowledge, monitoring, backup, how to take the backup, OS backup, database backup. All this stuff will be covered in AWS. You don't need to learn separately operating system, networking, security firewall, or storages. You don't need to learn all these technologies. Everything is going to be covered in AWS. So you need to be familiar with all these concepts to support the operations. Next, mobile application. Whatever apps you are downloading from Play Store, this comes under mobile application. It works on presentation layer, graphical mode. There are separate developers, iOS developers. What is iOS stands? iPhone operating system, Android. So iOS, Android, these are comes under operating system. So why do you need operating system? To interact with the hardware devices. Without operating system, we cannot interact with hardware. So iOS, Android, these are comes under operating system. Assume that you have a server. There's a server. I install operating system on that. First, take the hardware. On top of that, install operating system, either Windows or Linux. On top of that, install the Java. Why do you need a Java? To deploy or to configure any application like Tomcat server, JBoss server, it required a Java. Without Java, we can't configure this application server. After that, I told you that there are separate developers, UI developers. They're going to write the program for APIs, application program interface. Here we have a payment API, login API, order API, account API. When you log into the Google Pay, it asks for the login API first. That is called login API. We have a payment APIs. That is also payment APIs configured here. In Amazon, we are going to put the order. That is also called order API. So what are these APIs? Who are developed this by the developers? So in your mobile application, you can download this Flipkart of Amazon in your mobile. Does it mean that your application layer, data link layer installing in your mobile? In your mobile, you are not installing any data link layer or application layer. It is going to install only presentation layer. With a current temperature of 17 degrees Celsius, today's it is going to install only presentation layer. That is called graphical user interface. So, so where this server is hosted, it is hosted on internet. It is hosted on internet. So you can access this server either from laptop or from desktop. This is the database. Your application layer will communicate with the database server. In this database, all your data will be stored. So what kind of database we have here? There are two types of databases. So you can access this application either from laptop or a tab or a mobile. There are two types of databases: SQL database, NoSQL database. NoSQL database is nothing but document-oriented database. What is the difference between SQL database, NoSQL database? We'll see later in AWS. In AWS, we have a separate service called RDS. RDS stands Relational Database Service. In that, we'll discuss about what is SQL, what is NoSQL, where we use SQL databases, where we use NoSQL databases. So we want to host this application or database, we need this kind of infrastructure. So before cloud came into picture, all this infrastructure are on-premises data center. On-premises data center are a physical data center. On-premises are physical data center. Meaning of that, every company they have their own data centers. IBM they have their own data center. Wipro they have their own data center. What exactly data center? Data center is a physical location where the company will store all their data in one place, made up of network of computing, storage resources, and share various applications. I told you that to deploy the application, we need infrastructure. All this infrastructure is maintained by their own organization. IBM, they have their own data center. Wipro, they have their own data center where they're going to maintain all the data in their data center. They have their own infrastructure. The difference between physical data center, cloud data center. Physical data centers are physically available. We can find out that in the Google map. You want to find out where the IBM is, you can find the data center in Google map. It is physically available. You can go there if you have a permission. You can see the server storages in the physical data center. So physically available. That is called physical data center. But coming to the cloud data center, we can't find that in the Google map. We don't know where the data centers are. It is somewhere located on internet. So there is no physical access of the data center if it is cloud. Types of data centers: physical data center and cloud data center. Physical data centers we also call on-premises and cloud data center. This is about physical data center. Looks like this. These are called the rack. In this rack, we are going to insert the servers. What servers are? Blade servers. Example for blade server, this is called blade server. There are two types of servers, tower and blade servers. 15-20 years back, we used to use tower. But those tower servers occupies more space. That's why nowadays they are using blade servers. This is one blade server having hard disk, 8 hard disks. There are two types of storages, internal storage, external storage. This is the server with internal storage. Do you require 8 hard disks for installation of operating system? I don't require. Then why do you need this many hard disks? For fault tolerance. If one hard disk fails, we are going to install operating system on both the hard disks. Operating system install on both the hard disks. One hard disk fail, no downtime to my application, no downtime to the end user. One hard disk fail, your application runs on another hard disk because both the disk OS is installed. In both the disk, applications are running. Both the disk database is running. Even one hard disk goes down, no downtime to your application or database. What is the use of these many hard disks? It is for failover disk. If any one hard disk fails, it automatically replaces the failed disk with the spare disk. All these are spare disks. All these are spare disks. We have a separate concept called RAID concept, redundant array of inexpensive disks. That will be covered later. So this is called data center. In one data center, you might be having 5,000, more than 5,000 servers. All these are racks. In that rack, we are going to insert this blade servers. Challenges or problems with on-premises data center. Why the people are moving to the cloud? Why the cloud has lot of demand? Why not physical data center? Why not on-premise data center? So there are some challenges, problems with on-premises data center. What are those? Those are CapEx. CapEx stands capital expenditure. OpEx stands operational expenditure. Time consuming, maintenance, redundancy and scalability. So these are the challenges with on-premises data center. What is this CapEx? Capital expenditure. For on-premise data center, the company has to spend a lot of money, lot of amount for data center to procure the infrastructure, like servers, storages, switches, and routers. You take any data center, like you want to start data center with 5,000 servers. 5,000 servers means what? We need an area of 10,000, more than 10,000 square feet. So for this data center, they nearly invest minimum of 100 crores of amount. Lot of money is required to procure this hardware, and you won't be able to set up this data center very quickly. It will take minimum one to 3 years to build this infrastructure, data center. And maintenance scalability. What is this scalability means? Increasing, decreasing the capacity of your hardware. Increasing and decreasing of the hardware. In AWS, we call it as a scale in and scale out. Scale in and scale out. That is called increase and decrease. Currently, there are thousands users. I have 1,000 users. I set up a data center with 2 servers. I set up a data center with 2 servers. I have only 1,000 users. After that, my number of customers are increased. When number of customers are increased, there is a load on the server. Generally, if you are accessing any application on internet like Flipkart, Gmail.com, Yahoo.com, any application on internet, your applications are hosted on not on one server. Your application is hosted on more than one server. More than one server. Why? We need a backup. Means what? If this server is not responding, I have another server, same application hosted here. if this server is not responding, and this application server will serve the request to you. One server goes down, we have another server backup, so that there is no downtime to application. In the real time, for every server, there is a backup. Database servers, we have a backup. Application server backup, web server backup. For every server, there is a backup. And whenever we are trying to access any application on internet, the request does not directly send to the application server. Before that, there is a load balancer. Before that, there is a load balancer. We'll take one server, either Windows or Linux, and configure load balancer. There are so many softwares we have to configure load balancer. We call Apache, HTTPD, Nginx, HA proxy. All these are softwares to set up a load balancer. So we have a app servers here. In front of that, there's a load balancer. You are the customers, you are the users who are trying to access this application. So the request does not directly go to app servers. The request goes to load balancer. The load balancer takes the query or request from the client, from the customer, and send the request to the app servers. If this server is not responding, if it is busy because of huge network traffic, then the request sent to the another server. If this is busy, the request sent to the another server. Like that, there will be more than one app servers out there. Based on the network traffic, based on the load. Flipkart, they're maintaining more than 100 applications out there. That's the reason there is no downtime to the application. Amazon, there was no downtime for Amazon because Amazon is hosted not on one physical server. Amazon is hosted on multiple servers. The more number of servers, I can give the zero downtime. If you say zero downtime, what we require? We need more infrastructure, more number of servers. So the end user requests go to load balancer. Load balancer distribute the load to the application server. In the real time, we'll be having this architecture, either physical data center or a cloud data center. This kind of architecture we'll see either physical or cloud data center. Let us take, for example, Flipkart. You see, there's a load balancer. The request comes to load balancer. Load balancer send the request to the web server. Here also, this is also one load balancer. It distributes the load. So your Flipkart is hosted in AWS. Why AWS? I'll explain you later when we start AWS services. So any application that need a load balancer. So either physical data center or cloud data center, they're going to use this architecture. So these application server internally communicate with database server. So today I developed one application initially with less number of users. Initially with less number of users. I hosted my application with less number of servers. Because of I have less number of users, I hosted with less number of servers. But gradually, when my customers are increasing and lot of users are accessing my application, going forward, when my customers are increased, then these two physical servers can't serve the request. I need to add more number of servers. So when customers are increasing, we have to add more number of servers. If you are not adding more number of servers, in that case, my application servers cannot handle that much of request. So my hardware infrastructure does not support for that. So I did not scale my hardware. I did not scale my hardware or servers. To scale your hardware or server, generally, for example, because of lack of memory, my CPU utilization, memory utilization will increase on these servers. If any process running out of CPU, any process running out of CPU, what will happen? The process will get hung or freeze, hung or freeze because of running out of CPU or sometimes running out of memory. Out of CPU or out of memory, the process will get hung. We can't put active application. Or sometimes the application will respond very slowly. Why? Because of out of memory, because of out of CPU utilization. So in that case, what I have to do? I have to scale up my hardware. I have to scale up my hardware. Means what? I have to add more number of CPUs. Add more number of CPUs or more memory. Is it possible to add more number of CPUs on physical server directly when the server is up and running? No. We have to shut down the server, shut down it, add the CPU, shut down it, add the memory. For example, here we have a VM, virtual machine. Right now this VM having 4 GB RAM and 2 CPUs. Because of lack of memory, lack of CPUs, my application not responding or responding very slow. In that case, I have to increase my hardware. So here we have option called click on settings, click on add. What do you want to add? You want to add a hard disk, or you want to add a network card or sound card or a processor. You want to add a processor, click on this processor. You can increase number of CPUs. You want to add a memory, click on this memory. You can increase the memory, but the problem is you can't increase the hardware on running server. You have to shut down it. I have to shut down it, increase the hardware. If I shut down my server, downtime to my application, downtime to the end user. So you can't scale up or scale down your hardware on running server. So based on the load, I need to scale my application as well as my infrastructure. Initially, I started my application with 2 servers. With 2 servers and the 2 servers replicas. So tomorrow, my number of customers are increased. I have to add more number of servers. Add more number of servers. So I need to purchase the hardware and deploy my application. It is a very time-taking process. We can't add the server very quickly within 1 or 2 days. It will take more than 1 week. You have to purchase the server, install the operating system, set up everything. It will take more than 1 week. It's a time-consuming process. It may take sometimes 1 month also. That is called capital expenditure. So whenever the more number of customers are increased, you have to scale up your hardware, add more number of servers. Even though if you scale the infrastructure, after some days, my other competitors started the same application, same kind of application with advanced features, new features or advanced features. So slowly, my customers are switching to the other application. Nobody is in my application now. They are switching to the other application. My business is gradually reduced. So whatever infrastructure I've already purchased, I have to sell it in the seconds, in the scrap. If you purchase a server with 10 lakhs, after 1 year, nobody purchases a server with 10 lakhs again. I have to sell it 1 lakh, like scrap. So whatever investment we invested here, everything will be lost. So we already invested huge amount of money on hardware infrastructure. These are the challenges with on-premises data center. The other challenges with on-premises data center. Data center infrastructure management. To start your data center, I need a dedicated space, 5,000 or 10,000 square feet. I need a high bandwidth, redundancy. I need a redundant power supply, means continuous power supply. Support availability. I need a developers. I need a Linux administrators, Windows administrators, database administrators, storage admin, network team, capacity planning, higher maintenance effort, time consuming. We can't start this data center within a month, and leadership experience. They are the challenges with on-premises data center. In this scenario, when your application not widely used by the customers, so when there is no guarantee about your business, then why should I go for on-premise data center? I don't know that my application will click or not. So why should I invest this much of amount? And there's no guarantee about your business. And you cannot share your infrastructure to someone else. You can't ask other companies, please use my infrastructure. Why the other companies will put the valuable data in your data center? Why they believe you? They can't trust you, right? So here wasting a lot of money, huge amount of money. These are the problem with on-premises data center. Other challenges are business requirement, high availability, redundancy, fault tolerance, and scalability, elasticity, and scalability. The other challenges in on-premises or physical data center. Business requirement. Business requirement means application for revenue generation. No one will develop the application only for time pass. They need revenue generation. That is called business requirement. High availability. So creating architecture in such a way that your servers and applications are available, always available. If I deploy my application, that application should be always available. That is called high availability. There are two types here, availability and high availability. What is different between availability and high availability, we'll see later. But here, my application should be high availability, not availability. For high availability, we need to add more number of servers. I deploy my application only one physical server, and if I say that my application is high availability, that is not high availability. So high availability means what? Even one server is down, there should not be any downtime to my application to the end user. For that, we need to add more number of servers. The more number of servers, more availability. How these problems will resolve, we'll see in AWS. If there is a power outage or network outage in your data center, it will impact your application. That means what? I require redundant power supply, continuous power supply, network, high bandwidth to give the zero downtime to my application. So in case of application down for 1 hour or 2 hours or 3 hours, there will be huge impact on your revenue. Do you remember 3 months back, 3-4 months back, WhatsApp is down for 1 hour. 3-4 years back, WhatsApp is down for 3 hours. 7 years back, Facebook is down for 5 hours. If Google Pay is not working, all my customers are switched to the phone pay. If it is frequently happening, not responding Google Pay, then we'll uninstall it. We'll use only phone pay. That is called as a downtime. So that will be effect on your application. So not only you are losing the revenue, you'll be losing your customers as well. If Ola app is not working, we'll switch to the Uber app, right? So the customers also we are losing. So in this competitive world, you have to make sure that your application always available for end user. Your application always available for end user. That is possible in cloud. Your application should be highly available. Means what? There should not be any downtime. Cloud is AWS cloud saying that when you deploy your application in our infrastructure, in our hardware, in our data center, we are going to give the 99.99%, 99.99% downtime. That means what? They are giving only 1% downtime. 1% downtime, 99.99% they are giving nothing but it is not a joke. 1% means what? Throughout the year, they are giving downtime of 56 minutes, 56 point something, 56 minutes they are giving the downtime for throughout the year. It is not a joke. If anybody gives the 100% downtime, saying that if you deploy an application in my data center, I'll give the 100% downtime, zero downtime. If anyone say like that, it is 100% joke. No one can give the 100%. And there are two types of downtime. What are those we'll discuss in AWS. So high availability means what? Creating the architecture in such a way that the servers and applications are always available. So high availability always access your data or application over the internet. So there is no power outage, no network outage, no impact on your application. Okay, that's the meaning of high availability. Fault tolerance. Fault tolerance means what? If one server goes down, the application will, the request is sent to the other application server. Because there are more than one application server, the same kind of app is installed. One is goes down, request sent to another server. That is called fault tolerance. Elasticity and scalability. Elasticity means what? Increase your hardware. Because of lack of CPU, lack of processor, lack of memory, your application not responding, or application is freeze because of lack of memory. Then what your job? You have to increase your hardware. That is called elasticity. It is not possible in physical data center. You have to shut down your server, increase the memory and processors. Without shutting down, we can't increase that. But whereas in cloud, without without any downtime to your application, without shutting down, without any downtime, I can increase my hardware and running server. Scalability. Scalability means what? Today, if I start one data center with 2 physical servers, tomorrow my number of customers are increased. I have to scale up my hardware, add more number of servers, add more number of servers. After 1 year, when there's no business, my business is down, I have to remove those hardware. Here we are investing a lot of amount. Whereas if I go for a cloud, the advantage of the cloud is there's a concept of auto scaling. Auto scaling means what? Whenever the traffic increase, whenever the traffic is increased, it is going to add more servers. It is going to add more number of servers automatically. As of now, I started my data center with 2 servers. I'm using the cloud AWS. So If I configure auto scaling, if there is a more load on the server, immediately launch another server within a seconds. You are not going to purchase this hardware. You are not going to install operating system software or deploy application manually. Whatever the application running here, the same setup is going to create one more server. The same setup create one more server, launch the server immediately with no downtime. Even these three servers are also not sufficient for a network traffic. Or the more load on three servers is going to launch another server. The load on these four servers is going to launch another server. This is called auto scaling. Within a seconds, it is going to launch more servers as per your demand. Sometimes you know that Flipkart they're going to announce the sale January 31st. Laptop 1 lakh laptop is 25,000. They announce the sale only for midnight 12 to 1. In regular days, the traffic is different. When the announced 12 to 1 at January 12 to 1, 31st 12 to 1, the traffic is different, more number of traffic. In that case, these two servers are not able to handle that much of traffic. If I go for physical data center, I have to invest lot of amount. I don't know how much traffic will be there in the January 31st. So I have to add more number of servers manually. Adding more number of servers manually is very difficult job, time consuming process. Because this sale only for 1 hour, in a throughout the year only for 1 hour, why should I invest this much of amount here? If I go for a cloud, I'm going to use the servers pay as you go model. Pay as you go model. This is one of the good feature in AWS. What is pay as you go model? For example, these servers are launched whenever the load on these two both the servers launch on the server immediately. There is load on this app server 3 also launch app server 4. Load on this app server 4, launch app server 5. So whenever the load is increased, it's going to add more number of servers. When the sale only 31st 12 to 1, night 12 to 1, after 1 there's no load, no network, then these servers are automatically terminated. So we are going to configure some metrics in auto scaling. What we are going to configure metrics if the CPU utilization more than 80%, or RAM utilization more than 80%, launch one server. Launch the servers when CPU utilization, memory utilization more than 80%. At the same time, terminate the servers when CPU utilization, memory utilization less than 80%, terminate the server. Because the sale did only between 12 to 1. After 1 o'clock, there is no that much network traffic. Then these servers are automatically terminated. I'm going to pay to the cloud, AWS cloud, only for the servers which I'm consuming. If I use the server for 1 hour, I'm going to pay only for 1 hour. If this server I use for 2 hours, I'll pay only for 2 hours. They're going to charge the server in hourly basis. Even if I purchase the server from AWS for 1 year, if I use the server for only for 30 days or only for 30 hours, I'm going to pay only for 30 hours. That is called pay as you go model. So there is no huge investment here. There is no capital investment here, no capital expenditure. So whenever you require, you can take the server. If you don't require, you can terminate. You don't need to maintain any infrastructure. No premises required. Everything will be taken care by your cloud service provider. Okay, so tomorrow we'll continue what are these AWS services, what is the cloud deployment models, what is service deployment models. So today, tomorrow, day after tomorrow, the demo session, 3 days demo session. After that, we are going to start Linux basics. So after this demo session, please take the admission so that we'll start the Linux fundamentals, Linux basics for 1 week. After that, we'll start the AWS. So once you take admission, I'll provide all the documents, entry point of view questions, all this stuff. Any questions for today class? Okay, guys. See you tomorrow, same time.
Thank you.